Hello, this is Pavel. In distributed systems, all interactions between components can be categorized into three types: queries, commands, and events. In this video, I'm going to tell you the difference between these three and how they relate to DDS technology. The difference between these types, commands, queries, and events, lies in their intent. Commands' intent is to modify the state, so modify the data of the system. It usually uses request and response, and they can be rejected. Queries. The intent of the queries is to retrieve the internal state information from the system. They use as well request reply usually. And it's on-demand request for information. And events. Events describe the fact that occurred in the system. So it's immutable. It has already occurred. And for this type is usually use publish subscribe model of communication. And they can query data, they can carry data, and usually do not expect any reaction from the system, or not the reaction, but the response. And we can distinguish the events into two types. One is a notification, only notification. So it does not contain much data, and events events that are used to notify, to tell others that something has happened in the system. Something has occurred. But you do not get the state. So if you would like to know the state, you need to ask in these situations. So, for example, there is an event that the temperature is above a threshold. All right, but you don't know maybe you don't know the threshold, you don't know the temperature, you only know that something has happened. Then you've got an event that carry a state. These events are called event carried state transfer. And in this type of events, there is a state propagation. That means you publish events that has an information about state changes. Something has happened, and the event carry an information about that change. So the consumers can have the information about the state of the system in their local caches. They have copies of it. So you don't need to ask for data, because everything you would like to know about it is in your cache. So you know about the temperature, you know about the threshold, everything. But on the other hand, in this case, you send a redundant information with the event. For example, you can send all the information, all the diagnostic information about your device. So these differences between command, queries, and events lead to two system architectures. One is request and command driven architecture, and one is event driven architecture. So in request command architecture, you ask questions from others and you tell others what to do, and you wait for the response. But these can lead to tight coupling. So one one failure in your system can cause failure of the whole system. And these type of systems are usually less flexible to make a change because everything is connected together. Event-driven system, you ask for state changes and you tell others what you did. So the others can determine what to do. And in event-driven system, you usually don't wait for any response. So for example, when I want, in a request command-driven system, when I want the car is in the state that is stopped, I have to say, you braking system, start braking and stop the system. In the event-driven system, you ask for the change. You don't know the braking control system. You want the state of the car to be stopped. So you send a request, and who is responsible? In this case, the control braking system. Make a state change. So he starts to start braking, and after that he confirms that the state of the car is stopped. All right. So what else we got here? What else we got here? So when I'm talking about an event-driven system, we can refer to their data as data in motion. And when we talking about the system that uses queries, we talking about their data as data at rest, because the data in the system request reply, when you use queries, the data are stored somewhere, so they can be queried, and they are at rest. But the DDS technology is the event-driven technology, where data are in motion, constantly moving. And this technology does not allow to query information from others. So with, all right, message. So now you may wonder how you can get the right information from the DDS system that is using the data in motion. So the answer is by filtering. You filter the right information that you need. And how would you do that? How you do that? It can be done through topics in DDS systems, or it can be done by assigning topics to logical groups, to the partitions. So you see only the part of the data of your whole system. And within topics, you can use content filtering. You can filter the data by the content. So I want only the data between 20 and 50 degrees of Celsius. And I don't care about others. All right. But what would you do if you want to send a command to someone? In these cases, you can use a design pattern, which is called objective state design pattern. And in this pattern, you request the information. So you send the request to the system. That's the first. Someone subscribed to this type of events, and that someone is responsible for making the change. So the consumer of that event, of that request, make a change in the system. And after some time, after the state is changed, he sent a response. So he sent an objective state, the new state of the system, as a reaction to the requester. I have to say that these architectures are usually combined together, the request command driven and the event driven, because you need both the data at rest in your system and data in motion in your system usually. So these were types of interactions in your distributed system and how they relate to data distribution service. And if you are interested in data distribution service technology, give me thumbs up or make some reaction so I know that you are interested in DDS technology, so I can make more videos about it. So bye bye.